Welcome friends, let's take a look at the Laplace transform of f of t equals 1, and then some graphs and relating the graphs, some visual insight. So let's take a look at the following. We're going to do Laplace transform of 1. So by definition, is this integral that goes from 0 to positive infinity. Why is it this integral? And why is it that you take the function, in this case 1, and you multiply by e to the negative st? Well, if you're interested in the origins of this thing, it comes from basically series in a certain sense, and you can watch a video by Professor Maddock. And he gives a pretty detailed explanation of the origin of the Laplace transform y. For example, you multiply by e to the negative st. Anyway, so let's continue. Now I can carry out the integration here. So if you think about the chain rule and the way that operates, you would need negative 1 over s this way right here. And then e raised to the negative st. Why? Because you see, if you differentiate e to the negative st, it would bring down an extra negative s by the chain rule, but it has to be then canceled by negative 1 over s, because our original integrand has just 1 e to the negative st, right? There's no negative 1 over s here. So that's why you need an extra negative 1 over s. If that's too hard, you can just do u sub. All right, and then up here, just to keep things simple, I'm just going to keep an infinity there. Officially, you're supposed to write a limit as, say, b goes to infinity and replace the upper limit with b and all that. But let's say, for the sake of conciseness, this is equivalent to that. But we'll just keep it short, write infinity instead. And then I'm going to do minus, and then negative 1 over s, and then e raised to negative s times 0, because that's the lower limit. So with this in place, you continue. So it's going to be negative 1 over s, and then it's going to be e, because it's negative s times infinity, so you're going to have e2 in the bottom, and then s times infinity, like this, and then plus 1 over s. So it's going to be e to the negative s times 0, which is just e to the 0. Then you're going to have here negative 1 over s, e, and then s times infinity, so whatever s happens to be, it's usually meant to be a positive number here, otherwise this doesn't converge. I'll show in a second. So the point is that you're going to have s times a huge value, right? So you're going to have a huge value in the bottom like this in the end, so it's going to be 0. Plus 1 over s, which is then just 1 over s. Okay. So because e to the 0 is 1. So you have 1 over s. Now notice something, s has to be greater than 0. Like if s, for example, is negative 1, right, which is less than 0. See what happens in that case. Okay, so try it. You would have the definite integral, say, 0 to positive infinity. And if s were negative 1, then you would have 1e raised to the, right, of negative 1t, because this is like negative st, so it's negative 1 times negative 1 with the dt. So that would give you then the definite integral from 0 to positive infinity, and it's e to the positive t dt. But you see, when you differentiate here, what do you get? You would have e to the t between positive infinity, so to speak, and 0. But that's just e to the infinity minus e to the infinity minus e to the 0, you see, but it's infinity then, and e to the 0 is 1. So it's this situation, but that's just infinity, right? In other words, it diverges, you see. So the point is, s should be greater than 0, or you don't have a convergent integral as you need. Okay, let's look at some graphs now. So here we have the following. This is the function 1. So this is the function 1, the original function we're transforming, like this. And by the time you finish, you have the function 1 over s. So 1 over s looks like this, 1 over s. There's a relationship you should understand between these two here, right? So the y-coordinate in the panel on the right side, that's just equal to the following: the definite integral from 0 to positive infinity. And let's say specifically s has the value 1. Now remember here, this is the s-axis, okay? So if you set s equal to 1, you would have 1e raised to the negative t dt, like this. That's just a value of an integral, but the point is it becomes the y-coordinate on the graph here, like this. So let me just kind of separate this way, okay? So in other words, it becomes this right here. Right, when s has the value 1 right here, then the value is right here, see? It's also equal to 1 essentially. Y is equal to the definite integral from 0 to positive infinity. The function is 1, the one we are transforming. And then when s has the value 3, you would have e to the negative 3t dt. Okay, let's make it a bit smaller so it fits better. And then the value of that integral is the y coordinate right here in this location. See? Each one just represents, in a purely geometric sense, aside from any other interpretations, what it's telling me that when we integrate this, so negative 0 to positive infinity of 1e to the negative, so when s is 1, it's like this basically. So this is just area on the graph of e to the negative t. Specifically, so this is when s is the value 1, correct? So it's just the area, like the y coordinate right here. In a purely geometric sense, in terms of areas, it says when you take 1 times e to the negative st, when you set s equal to 1, because that's the coordinate right here, set s equal to 1, then the value, the y coordinate on this graph is the value of that integral, is just the area. Okay, that you get over here by integrating this, but specifically it's this one right here, let's be clear, right? If this is the original function 1, then the new integrand would look like this, would be e to the, and you're setting s equal to 1, so you'd have negative 1 times t. You see? Right here. So the value of this area, let me kind of emphasize this one more time. So definite integral from 0 to positive infinity, okay, of 1e to the negative 1t dt. This is just an area under a graph, and you see that it converges right here. That's what this is, okay, right here. I hope you can see that, but so the area there between t equals 0 and positive infinity under that graph, that's just represented on the right side by being the y coordinate. On the other hand, if you let, for example, s has the value positive 2, then you'd have e to the negative 2t. Okay, so that's the red graph now. So that would then be represented on the right side by saying that when s has the value 2, so this is s equal to right here. Let me move this into position. Right here, okay, like that. Then the y coordinate at that point, so that would be the y coordinate right here, okay, which is a half right there. You see this? The y coordinate here of 0.5. That represents the area under the red graph from 0 to positive infinity, and that's how you can relate these two graphs. This is all just what I'm showing you, consisting of the mechanics of finding, for example, the transformation of 1, and then understanding a bit more deeply what happens between graphs. But the specific motivation for using e to the negative st, again, you should watch this video by Professor Maddock from MIT. If you look it up, he'll give you a very nice explanation of the origin, and he relates it specifically to the fact that this is the continuous analog of series.